Hello, welcome to lesson 1-14, adding radicals. This is Mr. Thomas Wick here again. Our learning target today is going to be that I can add radicals. Now if you will take a look at your notes, you will see that just like with regular numbers, and when I say regular numbers I'm thinking about integers like you're used to seeing, or mixed numbers or fractions or decimals, 1, 3.2, 7/2, how we can add those together. Square roots can also be added together. The big difference is, though, now we're not going to necessarily be able to simplify the addition all the way down to one number. We might have a couple different radicals, or we might have a couple different numbers in our final answer. Now, if you think back to when we were adding polynomials, where we were adding like terms in the algebraic expressions, we're going to take a similar approach when we're doing radicals. Our radicals are going to have like terms to add. Just like we couldn't combine an x cubed and an x squared in the last lesson, we can't combine a square root of 3 and a square root of 5. We can only combine those radicals that have the same number underneath. And what we use vocabulary-wise to indicate that is a radicand. We should have already have that definition down in our notes for a radicand, but just a gentle reminder that radicand is that number that you see underneath the radical sign. Alright, so let's take a look at these numbers that we have as our examples. So in example 1, we're given 2 square roots of 3 plus 3 square roots of 3. Notice that we have the same radicand in each of these numbers. In both cases, it's a 3. So that's what we're looking at when we're looking at like terms, is these numbers underneath the radical need to be the same. Now in this case, this problem is set up well for us. We already have a 3 and a 3. So we know that that is going to be our like radical, and I know that underneath my radical I'm going to keep that 3. Now, the only thing else we have to do is now we're going to take these two numbers in front of the radical, the 2 and the 3, and since we have the like radicand, we can go ahead and add those together like normal numbers. So just like we would do 2 plus 3 is 5, we're going to do the same thing here, and we're going to get 5 square roots of 3. So we're just adding these numbers together as long as we have the same number under the radicand. Now let's look at example number 2. Notice this time we have a 50 and we have a 2 as our radicand. Notice that these are not the same. 50 is not the same as 2. So we can't just add these together yet. What we have to do is we have to see if we can get a like number underneath the radicand. Now square root of 2 is pretty much as simplified as you can get. There's no numbers that are squares that will go into 2. But let's take a look at the square root of 50. The square root of 50 could be broken down as 25 times 2. Now 25 is a perfect square. It is 5 times 5. So just like when you were doing simplifying radicals in the last lesson, we're going to pull that out. Since it's 5 times 5, if you take that out, it's going to be a 5 outside the parentheses. And we're left with only the 2 in the radicand. So now 50 is the same thing, or sorry, rather the square root of 50 is the same thing as 5 square roots of 2. Now we're going to bring down the square root of 2 that we already had. Now we can see that we now have the same number under the radicand. So now we know that our final answer is going to have a radicand of 2. And now we have to add our constants. Now, you have a 5 here. This one's a little less obvious though. When there's no number in front of there, just like when we had an x or a y with no number in front of there, we're going to treat it as if there is a 1 there. So we're going to do 5 plus 1, and that's going to give us 6, giving us a final answer of 6 square roots of 2. Alright, that's going to conclude this video. Go ahead and do the practice for 1-14. Check your answers and then get with your teacher to get an application. Alright, see you guys later.